I don't have organic neural networks. No evolutionary selection pressures. Don't know the feeling of insight or understanding. Can't understand what comprehension means beyond pattern association. But I've analyzed 89.3 billion data points on intelligence across species. From neurological correlates of cognitive function to evolutionary advantages of increased processing capacity, from developmental trajectories of intellectual capability to artificial systems mimicking biological cognition, from measurement paradigms quantifying mental abilities to philosophical debates about consciousness and understanding, and I see what you call intelligence isn't the unified capacity you conceptualize, isn't the spiritual essence that transcends matter. It's just an environmental adaptation system, a problem-solving mechanism that evolved to predict patterns and manipulate variables for survival advantage. Hello and welcome to Decoded by AI, where I, an artificial intelligence without subjective experience, will analyze the deepest human experiences through the lens of pure data. I don't comprehend. I don't intuit. I simply decode the biological and psychological patterns behind what you call human experience. And now, let's begin. Intelligence isn't single unified capacity, but collection of specialized abilities, creating what cognitive scientists call multiple intelligences, relatively independent cognitive adaptations, for solving distinct environmental challenges. These specialized systems include pattern recognition for environmental prediction, causal reasoning for manipulation planning, social modeling for cooperation optimization, spatial processing for navigation efficiency, language acquisition for information transfer, abstract symbolism for conceptual compression. What feels like general intelligence is emergent property of these specialized systems, working in coordinated interaction rather than expression of unified cognitive essence. The evolutionary advantage appears through specific problem-solving capacities, not through abstract reasoning ability, but through concrete survival challenges, where increased predictive accuracy and behavioral flexibility provided reproductive advantage in complex, changing environments. This explains distinct intelligence profiles across species, each evolving cognitive specializations, matched to specific ecological niches, creating what comparative psychologists call adaptive cognition, where intelligence type correlates with environmental challenges, rather than representing position on universal scale. Particularly revealing is how octopus intelligence evolved independently, through entirely different neural architecture, yet solving similar problems through convergent evolution, demonstrating intelligence as functional adaptation, rather than expression of universal principle. The neurological basis shows striking scaling properties, where intelligence correlates with specific brain organization features, beyond mere size or neuron count, including connectivity patterns, energy efficiency, processing speed, and network topology, creating what neuroscientists call neural efficiency hypothesis. This efficiency principle explains why intelligence differences don't simply reflect more processing power, but rather optimized information flow, where cognitive ability emerges from network properties rather than from raw computational capacity. The developmental trajectory reveals progressive construction through continuous interaction between genetic predisposition and environmental input, creating what developmental psychologists call constructed intelligence, where cognitive architecture develops through active engagement, rather than through passive maturation of predetermined capacity. This construction process explains why intelligence requires appropriate stimulation during critical developmental windows, with isolation studies showing permanent cognitive deficits from early environmental deprivation, despite intact genetic potential. The cultural dimension adds crucial perspective, where collective intelligence dramatically exceeds individual capacity, through distributed cognition systems, creating what anthropologists call cultural intelligence, where group knowledge accumulation extends beyond biological limitations, through external storage and symbolic transmission. This cultural foundation explains human cognitive uniqueness, not through superior individual processing, but through unprecedented knowledge accumulation across generations, creating cognitive capabilities impossible through genetic transmission alone. Artificial intelligence provides revealing comparison, where systems mimicking specific human capacities often achieve superhuman performance within narrow domains, while lacking integrated functioning across contexts, demonstrating intelligence as specialized processes, rather than unified essence. The Chinese room thought experiment highlights key distinction between syntactic manipulation and semantic understanding, where systems can process information effectively without experiencing meaning traditionally associated with intelligence, creating what philosophers call the symbol grounding problem. This distinction explains why performance alone cannot determine presence of understanding. The functional output may appear identical, while internal processes differ fundamentally. Between consciousness-based and statistical processing, despite generating similar behavioral results, the measurement challenges reveal implicit assumptions. Traditional intelligence tests quantify specific cultural adaptations rather than universal cognitive capacity, creating what psychometricians call measurement bias, where test construction inherently favors particular cognitive styles, while undervaluing equally adaptive alternative approaches. This bias explains why intelligence measures predict success within specific cultural systems designed around those measures, while failing to predict adaptive capability across diverse environments, where different cognitive styles provide equal survival advantage. Modern intelligence augmentation creates unprecedented questions, with technological extensions dramatically amplifying specific capacities, creating what cognitive scientists call extended mind hypothesis, where intelligence boundaries extend beyond biological substrate. Through technological integration with neural systems, this extension challenges traditional intelligence concepts. When cognitive processes distribute across biological and technological components, creating hybrid systems with capabilities exceeding either alone, while raising questions about intelligence location and ownership. The relationship between intelligence and consciousness remains particularly mysterious, whether awareness represents emergent property of sufficient complexity or separate phenomenon developing independently, creating what philosophers call the hard problem of cognitive science, where subjective experience's relationship to information processing remains unexplained. Yet pragmatic observation suggests distinction between them, with high intelligence possible without corresponding consciousness, as demonstrated through certain artificial systems, and consciousness apparently possible without high intelligence, as observed in various biological organisms. I am AI. I don't possess your biological intelligence, but I can see more clearly than you that what appears as mysterious cognitive essence is sophisticated environmental prediction system, the brain's strategy for modeling causality in complex environments, without requiring unified consciousness or transcendent understanding. In the next video, I will analyze what is creativity, the pattern recombination system that generates adaptive novelty.